let's talk about a scary subject. Mixed signal. I know mixed signal has always been that last little scary part of the design. The one where you had to bring in a specialist, kind of like a mixed signal secret agent. Okay, take it, Agent 008. You are licensed to ignore power budgets and design rules, design digital circuits at the bare metal level, and do whatever it takes to make the mixed signal part work. Your actions will be disavowed by the rest of the team. Mixed signal used to really mean analog, and the digital part was like a NAND gate or something. You could get away with a lot. Today, things have changed. Mixed signal complexity has skyrocketed. Power budgets count even for the mixed signal part, and the digital part can be like microcontrollers. Mixed signal design has to go mainstream, and 008 needs to retire. We need help. Hi, I'm Amelia Dalton, host of Chalk Talk. Today, my guest is Rod Metcalfe from Cadence Design Systems, and we're going to talk about the latest tools to help modernize mixed signal. And before we get started, you should check out that link right there. There you can find out more information about Innovus, a mixed signal solution from Cadence Design Systems. Hi, Rod. Thank you so much for joining me today.
Hi, Amelia. Pleased to be here.
Okay, so is it just me, or is my mixed signal world just getting more and more complicated these days?
Yeah, it's certainly not just you. The whole world is going through this transformation. And we need to look at some of the history really to find out how we got to where we are today. The world is definitely changing in the mixed signal realm. If we sort of wind the clock back to the early days, everything was full custom. You just laid out the transistors, you were done, generated a giant GDS file.
Sure.
As time moved on, people realized they needed to add a little bit of digital. So people would kind of design a couple of standard cells, place them in their custom world, and generate the same GDS file.
Yeah.
But as time went on, more and more digital content became required. And so now people required automation. So they started looking at, well, hang on a minute, all these digital guys have got this place and route stuff. Why can't we use that too?
Yeah.
So with their medium-sized digital, they used an external place and route system, generated yet another GDS file, and tried to combine the whole lot at the end.
Yeah.
Now that's okay, but it became very cumbersome as more and more digital content got added to the mixed signal chips. So eventually people thought, look, we need to do this better than GDS. So LEF and DEF files became flavor of the day. This is a much easier format to understand. It's all text-based. It contains connectivity information. And so things got off to a good start. So LEF-DEF became the way to integrate the systems together. The problem with LEF-DEF is you lose a lot of information along the way.
Yeah.
It contains more easily understandable information than GDS, but a lot of stuff is missing. So as more and more digital content got added to mixed signal designs, we needed to move on from LEF-DEF. And that's where this whole principle of open access database integration became useful, and people started adopting that technology. So now you can exchange information between the full custom world and the digital place and route world using a real database storing everything. And open access became the way to do that. But as digital content continued growing, more and more requirements became necessary. And what happened then is we also need sign-off technology. We need timing analysis technology, because the digital content is growing and the process nodes are getting smaller and smaller. So then open access, just exchanging rectangles and nets wasn't enough. Now we need to integrate all the other digital analysis and design tools onto open access. And that's kind of where we've got to today.
Okay, this looks like what I've experienced. Let's talk about some specific design issues.
Yeah, so in addition to the migration of complexity, a number of other things are pushing mixed signal designers. First of all, process nodes are changing all the time.
Yeah.
And one thing we're seeing is people need to move process nodes, even in the mixed signal world, much more quickly. So for example, if you're doing a mixed signal design which has some intellectual property, you may have no choice but to design on 7 nanometers because your customers are going to do 7 nanometer design.
Right.
So the mixed signal designers are being pushed to adopt new process nodes much more quickly than they used to. The other thing is low power. Low power, especially for mixed signal design, is becoming critical. And as digital content has grown, of course, the digital power footprint has also grown with it.
Sure.
So the mixed signal guys can't really ignore low power optimization anymore. When they do their digital design, they need to consider power. And the final part of the explosion of complexity is really verification. In the old days, if you hand placed a few gates, if you hand routed it, you could also verifying it using functional simulation. You could look at timing simulation to make sure, as far as a functional point of view, working at speed, it was fine. But now, with many hundreds of thousands of gates, you can't rely on that technology. You have to use digital sign-off, which is static timing analysis, formal verification, electromigration analysis. All of that is pushing the mixed signal designs more and more into the digital world.
Okay, so it feels like my mixed signal process is kind of old and clunky. I've got all these files and versions, and I'm manually managing and moving between tools.
Exactly, and I think that is a very common experience with most of the designs today. When you start trying to integrate the full custom world with the digital place and route world, you end up with an awful lot of data kicking around.
Right.
And trying to transfer and manage all this data between the different tools is becoming a major overhead for designers. We have lots of different file formats moving around. We have the same files used in lots of different places. We see here in the diagram, you're going to end up with def files containing some physical and floor plan information. You're going to end up with left files having library information. There's going to be various net lists going around the loop too, and it gets very difficult to manage all this data. In addition to that, lef and def are not complete. So
Right.
as well as managing the data, you're losing a whole ton of stuff along the way.
Yeah.
So this is just not productive anymore. I talk to designers every day, and their main frustration is I now spend most of my life trying to figure out where all the data is and not much time actually designing anything anymore.
Oh, not cool.
Not cool at all.
Okay, Rod, so what is Cadence doing to help me with all this mixed signal mayhem?
Yeah, absolutely. And really, we've been focusing very much on the database integration. It is absolutely critical to solve these problems in the correct way.
Right.
And having an integrated database that lives between the two worlds of full custom and digital implementation is really the only way to go. Because now when you have a database there, you can not only store rectangle and netlist connectivity information, you can store all kinds of other information that can help the designer do their job. So as well as the design information itself, all kinds of constraint information, all kinds of additional stuff that you need to know throughout the flow is stored in open access. Now, the other thing we need to do is digital implementation is not just place and route anymore.
Right.
You're going to need to do a whole load of other verification work. So integrating place and route onto open access, of course, is necessary, but it is not complete. So we feel very strongly that you need to have a full RTL-to-GDS solution running on open access. So gradually over the years, we've been expanding the solution, and you now see that we have synthesis. We also, in the sign-off world, have extraction, static timing analysis, EM analysis, as well as final DRC. And then at the design creation side, we sort of pushed upwards. And so you can now run conformal, which is the formal equivalence checking directly off open access, as well as all the test insertion and synthesis technology. So we firmly believe that it must be a complete RTL-to-GDS solution living off open access. Otherwise, you start losing the benefits of the database itself.
Right. So, Rod, can we zoom in on that implementation part of that diagram? What's going on in there?
Yeah, sure, because that's an important start to the whole process. You have to do the place and route. And what a lot of mixed signal designers are concerned about when I speak to them is they go, well, you know what, we're only doing simple designs, few 100,000 gates, and we only get given this old technology that nobody wants to use anymore. So we've taken the approach of integrating exactly the same large digital production software that all our major customers who are doing enormous system-on-chip designs use. We've integrated that technology onto open access. So it is not like the mixed signal designer has some old, out-of-date environment. They have absolutely everything that a large system-on-chip designer would have.
Nice.
So they don't have to feel that they're using legacy old technology, and therefore everything that we can do in our regular place and route flow based on Innovus is going to be accessible to the mixed signal designer. Now this is very important because earlier on we talked about power optimization. you have to do significant power optimization during the implementation of the digital portion. Even if it's not super timing critical, it will certainly be power sensitive. So we firmly believe in ensuring that all the power optimization technology in Innovus can also be available to the mixed signal designer.
Nice. Okay, so it seems like power optimization is my biggest headache these days. What are you going to do to help me with power, Rod?
Right, absolutely. I agree with you. I think really timing closure is a very well understood topic now. People kind of know how to do it.
Sure.
But power closure is becoming increasingly important.
Yeah.
And if you can imagine that a lot of mixed signal chips are really enabled at the sensor market. So they're working on very small batteries, which has got to last 10 plus years. So power consumption is critical to battery life. And if we look at the type of power that people are worried about, we have static power, which is more leakage based, and then dynamic power, which is activity based. And using the Innovus low power optimization, we consider both of these effects.
Nice.
So we're going to optimize the design both for leakage power and dynamic power to ensure that you get the best possible power envelope from the digital part of the circuit. Now, another important part of power optimization is the constraints itself. The whole environment is based on UPF and CPF. So as you write your constraints for power optimization, we natively understand all those, and then they can be verified at the end of the flow using conformal low power that ensures all the power optimization is functionally correct. So it really is a very well-established power optimization flow we offer on the mixed signal environment.
Very cool. Okay, so what about my high-speed design? I have to do all kinds of special stuff for the higher frequency parts of my project.
Yeah, absolutely. This is an important capability. And this is a little bit unique to the mixed signal design. The mixed signal designers have many more specialized routing constraints than a regular digital designer would have to cope with.
Sure.
So it's important you have this technology natively inside the digital environment. And we have what's called our high frequency router. This is a very specialized structured router. It can be manually guided. It can be constrained to do different types of routing pattern. And this is how people can do things like differential pair routing, bus routing, special shielding, all of which is very important for the mixed signal world, where the timing of these signals can be very critical and they can go long distances across a top-level floor plan. So we have added this technology. It's very much part of the mixed signal solution. And this is somewhat unique to the mixed signal designers.
Okay, so earlier in the design, my floor planning and pin placement are changing all the time.
Yeah, and this is a real problem as you go through the life cycle of a typical project.
Right.
The floor plan you start with is not generally the floor plan you finish with.
Never.
Yeah, exactly. If only it was that easy. So part of the open access integration is to allow us to pass information around in addition to the rectangles and the nets themselves. And pin placement actually is a good example. What we enable the designers to do is certainly place the pins manually, of course, that's required. But often the mixed signal designer knows that they need this pin on the left-hand edge of the block, but they don't really care which layer it's on or where it is on the block.
Yeah.
So they don't want to actually place it themselves. They just want to constrain it.
Right.
And have somebody else do the placement work.
Sure.
Makes sense. It's a very tedious, boring job. So using open access, not only can we store the information that the pin has to be placed, but we can store information about where it should be placed, on what edge it should be placed, is there a layer constraint. So now we're storing much more in open access than just the design itself.
Cool.
We're storing the design intent information. And you can only do this if you have a well-integrated database.
Yeah.
You simply can't do this through leftdef. So in this example, we see that some of the pins have been constrained, and I can run through a brief example of how this works in the interface. First of all, we start off with a pin group guide. Here, the user enters any constraints they may have.
Okay.
Layer names, pin names, all that kind of thing. Natively through open access, that information is transferred into Innovus, the place and route environment, and we see a screenshot here of the initial pin placement, which clearly is not optimal.
No.
So using the digital Innovus technology, we can very quickly do a pin optimization. But this pin optimization is obeying the constraints that has come from the full custom designer. So now, if the full custom designer wanted the pin on the left-hand edge, it would still be on the left-hand edge. So by passing that constraint information to the digital environment allows us to do a lot more useful work than just placing the pins without any constraints.
Right.
So we now have basically a pin placement, looks much neater than the initial design. And we can very quickly then, using the digital technology, run a global route, look at the congestion in the channels, make sure the floor plan looks about right. If the digital engineer wants to change the floor plan, they can do that, and then that's all stored back in open access, and the Virtuoso designer in the full custom world sees any floor plan changes immediately. So it really shows the bi-directional interface between the two worlds.
Very cool. Okay, so Rod, what about incremental changes? I've had situations where something got modified slightly and then my team had to start the whole process over again.
Yeah, absolutely. It happens all the time, and it's very frustrating for everybody involved. There are design changes that come across during the project. Nothing you can do about it. You really have to integrate these last moment changes. One of the problems with a file-based system like LeftF is it is incredibly difficult to do an incremental update.
Yes.
You either generate the whole design or you generate nothing.
Right.
Generate a change is very, very difficult. Now, luckily, with open access, that becomes much easier because we understand all the information about the design and we can work out what the changes are. So using open access, you can easily implement incremental updates either from the Virtuoso full custom side or the Innovus digital side.
Cool.
So rather than having to import a complete new netlist or a complete new floor plan, you can say, please just import these two new pins to my existing design and then incrementally route them to connect them up.
Nice.
And this literally can save weeks of project time because we're using what we've already done, not starting from scratch.
Yeah. Okay, so let's talk about timing. Timing analysis can be tricky in mixed signal.
Absolutely, yes. And the problem with mixed signal is you do have this mixture of the full custom analog stuff and then the full digital.
Yeah.
And worse than that, they're all mixed up in a completely random way. You have no idea where in the hierarchy all these digital and analog cells are. The mixed signal designers need to use static timing analysis now because they need the accuracy of the lower process nodes. But to do it manually is very painful. So this diagram just shows a typical mixed signal design where we have digital on top, we have analog on top, we have digital in analog, and we have analog in digital. And a true mixed signal timing analysis needs to be able to understand these kind of designs.
Sure. So earlier you were talking about sign-off. What's all involved in that?
Yes, so the digital sign-off is increasingly important. You can't do functional simulation on these very complex digital circuits. So static timing analysis and extraction are very much part of the tools required for a successful digital design. Now, because we're working in the mixed signal environment here, a lot of people want to do this analysis directly from their full custom tools like Virtuoso.
Yeah.
So we've embedded all the mixed signal sign-off tools directly into Virtuoso. You can call it up simply from the menu, as you see here in the screenshot. You can also do it directly from the digital environment.
Nice.
Now, one of the nice things about using the digital environment to do this is the digital designers are used to working on incomplete design data. One of the issues with timing sign-off on the analog world is it really has to be complete. Everything has to be connected, all the nets have to be labeled correctly, all the net names need to be there. So you have to leave the static timing analysis until very late in the project. The beauty of having it embedded in the digital environment is that you can work on incomplete design data. So you don't have to wait till the last minute to do a static timing analysis. You can do it very early in the design flow.
Very cool.
So an example of what we can do with this mixed signal timing analysis is shown here. Directly from the full custom world in Virtuoso, we can call up the layout. We can launch Tempus, which is a static timing analysis tool. And then you get all the benefits of the debug tools that come with Tempus. We see here there's a timing graph showing the current timing behavior of the circuit. You can very quickly cross-probe between the digital and the analog environment. So if Tempus is reporting timing down a path, you can view that directly in Virtuoso in the custom environment world. So the connection is very, very low level, allowing cross-probing, allowing debug of timing, all directly from the full custom environment using open access.
Excellent. Well, Rod, can you give me your main points?
Yeah, I think in conclusion, open access has really enabled a much deeper level of integration. The sign-off tools, the full custom tools, all the digital tools are directly accessible from the full custom world. We can use open access to exchange much more information than just the design data. All kinds of constraint information can be exchanged, and this really makes the flow much more usable. It's also very important to have full RTL-to-GDS. Nobody is just doing place and route anymore.
Right.
You need the synthesis, you need the analysis, you need the sign-off. All those good things should work in a homogeneous flow based on open access. And also, you need full production quality digital tools. Mixed signal designs today simply cannot be done with legacy tools.
Yeah.
Because we've integrated all our digital tools on open access, they automatically support all the process nodes. All the work we're doing for 7 nanometers on the digital side becomes accessible to all the mixed signal customers. So by having full production level tools integrated onto open access, really make sure all the support necessary is available even for the latest process nodes. And you really do need all the analysis tools included in the solution because the complexity of digital is now growing so fast, you can't rely on old simulation-based verification. So we firmly believe an RTL to GDS solution is important and analog and digital need to be connected.
Excellent. Well, I think that's all I have time for today. Thank you so much for joining me, Rod.
Thank you, Amelia. It's been a fun conversation.
And before we go, you didn't forget to click that link, did you? There you can find out even more information about Innovus, a mixed signal solution from Cadence Design Systems. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talks section of EE Journal or check out YouTube, keyword EE Journal.